Bismillahirrahmanirrahim. Dear students, this is the Pakistan International School time, and we are continuing the lecture number 32 now, and number 16, grade 12, radical substitution reactions. In the previous lectures, I told you how the radical substitution reactions are going to be taking place. So, interesting information. If you see open page number 118, and yesterday also I told you how the arrows are going to move from one place to other place. So when the reaction mechanism are being described, we use the curly arrow. So there are two types of curly arrows. One is a half curly arrow, and another is called a full curly arrow. So how we know that the half curly arrow is used and full curly arrow is going to be used? In the previous lecture, somehow I told you about this one. Suppose this is the bromide. Bromide radical. This is a bromide radical, and this is a methyl radical. So there is a on the picture here. So there the deficiency of one electron pair. So this unpaired electron, if the unpaired electrons move, so the half curly arrow is going to be shown. Half curly arrow. When the one unpaired electron is going to move towards the electron deficient. So you will get methyl bromide. This is methyl bromide. In the second case, if the bond is broken down, this one, this is now this is the shared electron pair. Here is the movement of the unpaired, and here is the movement of the paired electron, and there is the carbon, and there is a bond between carbon and hydrogen, and there is also bond between carbon and hydrogen, and this bond is also between carbon and hydrogen. So this bond is going to dissociate now. So this is a full arrow. It shows a full arrow. Movement of the bonded electron pair. This bonded electron pair is going to be moved. So you can see that bromine, so this is now separated. Bonded electron pair between the carbon and bromine, like this. This is a cross dot formula of the methyl bromide. So this is a differentiation between the movement of the electron pair. Same case, there is a hydrogen which has only one electron, and there is a bond between chlorine and chlorine. Bond between chlorine and chlorine, like this. So this is the again bonded electron. So when the bonded electron is going to be moved, so you will find also a curving arrow. So students, there is a movement of one electron different. So the formation of bond taking place. It means that this bond is dissociated. Chlorine-chlorine bond is going to be broken down. Chlorine-chlorine bond is broken down, and hydrogen and chlorine bond is going to be formed. So this bond is going to be broken down like this one. So what you will get? Hydrogen, one electron of the chlorine, to give a hydrogen chloride, and plus chlorine atom. If you are going to write chloride ion, must put the negative charge because 8 electrons are there. So this arrow indicates that this electron is shifted to make a pair between chlorine and hydrogen, and they are going to formation of bond between the hydrogen and chlorine. You are seeing this one, and this chlorine atom is going to be removed in the form of chloride ion, and the 8 electrons are surrounding it to make a negative charge. So this is the phenomena of moving electrons. So here also, when the reaction mechanism are being described, Carney-Arrows mechanism is going to be shown, used for the movement of pair of electrons. So there are two kinds. One is a similar non-bonded electron pair and another bonded electron pair. The beginning of the arrow, this is the beginning of the arrow, this is the beginning of the arrow, this is the beginning of the arrow, shows where the electron pair starts, and the arrow head shows the electron is going to be ending. Here is the head of the arrow, and bond is going to be formed, and here is going to be starting. Here is starting, and here is going to be one bond is going to be formed here. So now, in the first case, I told you bromide ion to the region between the bromine and the carbon. So there is a unpaired electron is going to be formed. So that's why half-headed arrow. Formation of covalent bond between the bromine and carbon. A half arrow is used to show the movement of single electron pair in reaction involving radical, and half arrow head shows where it is going to be and up starting. This example is given, I told you, I've written in your book also. Curly arrows show the movement of electron pairs, and electron pairs start here and finish. The half curly arrow shows the movement of single electron, unpaired electrons, single electron, unpaired electrons, and the complete arrow shows the movement of the paired electrons. So this is mechanism just is going to be shown. Now actually chemical reaction is given here. Now students, there is the reaction mechanism. Reaction mechanism of radical substitution reactions. Reaction mechanism of radical substitution reactions. Now, in the radical chain mechanism for the reaction of methane with bromine, already I gave you example in the previous for the movement of the arrows. The mechanism for the bromination of methane is given below here, but the mechanism of chlorination of higher alkane is same. Note that it contains 3 distinct types of steps depending upon net change in the number of the radicals that are present. Step number 1. Step number 1. Initiation. Step number 1 is the initiation. Means how the bond is going to be broken down between bromine and bromine like this one. So like this. So this bond is going to be broken down. Start to break. Dissociation of bond, off curly arrow. Shifting of one electron only. So this is the initiation, and we need the ultraviolet light for this one to break the bond between chlorine, bromine and bromine. So here bromine free radical. Unpaired electron, odd number electrons without any charge. This is a bromine 1 free radical and this is a bromine other free radicals. There the movement of one electron, that's why the half curly arrow is going to be shown here. This is influence of diffused sunlight. Heat or ultraviolet light is going to be used to cause the weak bond undergo homolytic cleavage. Homolytic means same. These atoms are same. Cleavage broken down. Homolytic cleavage between bromine and bromine taking place. Two bromine free radicals. These are the free radicals, not home radicals, wrong. Free radicals. Radical means a positive negative charge. It's a free radical without any charge or number of electrons. Starting the chain process. Now step number 2, propagation. Propagation. A bromine radical, which is a very reactive now, bromine radicals, which is ready for reaction, very reactive, abstract the hydrogen from the hydrogen bromide, or it abstract the hydrogen from methyl group to form another molecule of hydrogen bromide and methyl free radical. So now bromine free radical. This is bromine free radical and abstraction of hydrogen from methane. This abstraction. So there is a bond formed between bromine and hydrogen. So this is equivalent like this. There is half curly arrow movement of the electron towards the hydrogen, and this bond is going to be broken down. This hydrogen bond is going to be broken down. So what happens? You will get methyl radical and hydrogen bromide. Methyl radical. This is also a free radical. Methyl is also a free radical, is going to be formed here. Hydrogen, the bond is going to be formed between hydrogen and bromine. This is a free radical, and there is one electron to form a bond between hydrogen and bromine, and this is dissociation of bond between the hydrogen and methyl group. So you will get a methyl free radical. Okay, so this is said dissociation of the bond. There is a dissociation of the bond, and this methyl radical is a very reactive in nature. Free radical methyl. So now there is a dissociation. Like this. And the bond is formed between bromine and methyl, like this. So this bond is going to be broken down, and the new bond is formed between the alkyl radical methyl and bromine. So that's why bromine again free radical is going to be formed, because one is going to be separated out. This is a free radical and methyl bromide is going to be formed, or bromomethane is going to be formed here. So this is a bromine dissociation bond, same as this same. This cleavage in the presence of temperature, high temperature, or the sunlight. So this free radical is already here present, which is a very reactive in nature. So here is the same free radical. So cleavage are homolytic. Homolytic cleavage taking place between bromine and bromine. There is a dissociation bond, and new bond is going to be formed between bromine and methyl group. So this bromine free radical is going to be formed, and there is a formation of methyl bromide. So this step is called propagation. There is another one also. There is another. If we have two methyl free radicals, or I can write it in this form. Like this. So there is a formation like this one. Half curly arrow. Half curly arrow shows that there is a formation of bond between methyl and methyl radical to form ethane. This ethane is going to be formed here. Like this. Half curly arrow. There is a half curly arrow between the two methyl radicals, which are free radicals and very reactive in nature, and you will get the ethane. Now, if we are now reversing this, listen, this is the cleavage of the homolytic bromine atoms. Now, this is a reverse process now. Listen, again, this is a bromine, and this is a free radical, and this is a bromine, this is a free radical, like this one. To give and bromine molecule. They are going to form molecule, just like ethane was formed. So this is the reverse of this step, first step. Now formation of the bromine, and also there the formation of bromine and methyl. Bromine on the same processes. Like this one. So this is a bromine free radical, and this one is a methyl free radical. This is a free radical. This is a free radical. Only unpaired electron, they are going to form a bond, that is a bromomethane or methyl bromide. So dear students, this is the termination step. We call termination products form. Step number 3. This step number 3 is called termination, where you are forming, making products. Various reactions between the possible pairs of radicals allow for the formation, I told you, formation of ethane, formation of bromine molecule, formation of methyl bromide, bromomethane. This is the end, termination or product methyl bromide. These reactions remove radicals and do not precipitate for the cycle. Now this is going to be complete here for the reaction mechanism of the radical chain mechanism for the reaction of the methane and bromine molecule. How the movement of the electron taking place either in the free radical form or in the pair form or bonded pair and lone pair, and where we use half curly arrow and where we use full arrow. Now students, we have in organic chemistry oxidation and reduction of the organic compounds. Oxidation and reduction in organic compounds. Oxidation, capital O, reduction, capital R. Organic compounds, addition of oxygen. Addition of oxygen is called oxidation, and removal of hydrogen is called oxidation. Removal of hydrogen is called oxidation, and addition of oxygen is called oxidation. Increase in oxidation number 1 to 2 to 3 is also called oxidation. Loss of electron. Reduction, addition of hydrogen. Addition of hydrogen is called reduction. Removal of oxygen is called reduction, and gain of electron, decrease in oxidation number is called reduction. So you done in the grades, lower grades for oxidation reduction, so we use methods. So dear students, where we completed the hair alkanes. Now alkenes. CnH2n. This is the general formula for the alkenes. So there is a nomenclature. Double bond contains, alkenes contain double bond CnH2n. So suppose I am going to write first simple. Like this, 1, 2, 3, 4. 4 carbon atoms in alkene, double bond show alkene, valency carbon should be 4 rather than 1. So a simple rule for alkene and alkyne both. Select the longest carbon chain must contain double covalent bond. When you are going to select the longest chain, so this chain must contains double covalent bond. If the longest chain does not contain double covalent bond, this will be wrong. This is the first very important rule. Second, starting from here, double bond is between 1 and 2 carbon inside 1 carbon. And here, if we start 1, 2 on 3 carbon. So rule is that lowest carbon, nearest double bond. So this is called 1-butene. 1-butene. 1 indicates the position of the double covalent bond, 4 carbon, but in identification for the double covalent bond. So this is a simple. This is the simplest one. By this one, starting from here 1, 2, on the carbon number 2, there is a double covalent bond. Starting from here 1, 2, 3. On carbon number 3, there is a double covalent bond, and on carbon number 2, there is a adjacent methyl group or branch. Now, what you prefer? The first rule is that I told you select the carbon-carbon containing double bond chain. So it means 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5 must contain double covalent bond. Then starting from here 1, 2 on the carbon number 2, this is the methyl group. And here carbon number 2, there is a double covalent bond. So now you have to prefer double covalent bond, not the branch. You must start the numbering from the double bond if equal position of the branch, additional group and double covalent bond. 1, 2, methyl, 1, 2, there are double bonds. So let's start from here. Like this. So 4 methyl, 2 pentene. 4 methyl, 2 pentene. Like this. So must contain this one. like this. Now, the students, you are seeing that double bond is here. So, if you start from this side, 1, 2, 3, 4, 5 longest chain. 1, 2, 3, 4 longest chain. 1, 2, 3, 4 longest chain. 1, 2, 3, 4 longest chain. If I go straight, 5 carbon atoms are there. Longest chain is 5. Longest chain is 5. So that's why, as I told you, if there is a double bond or triple bond, you must select the longest chain which contains double bond. Must. It means that 3 choices here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like this one. Must contain double bond now. Second is that if from here you are seeing on the double bond on the first carbon. 1, 2, 3, 4. 1, 2, 3, 4. This is all your choice. Like this. This is the branch. And there are 2 carbon atoms, so we call ethyl. 2 ethyl. 2 ethyl. And double bond bearing first carbon. 1 butene. 2 ethyl, 1 butene. So we will continue this lecture, students. Alkenes, their nomenclature, and this is long chapter. So you have to see the rules and also solve the questions which are present in this book also. Thank you very much.